Hello everyone. So I recently did a sanity check on the scheduler. I do this sort of thing from time to time to make sure that the updates that I've released haven't screwed something up. So I thought I'd make a quick video showing my process. It's actually not really a simple matter to check the scheduler to ensure that it's working properly, because at least 75% of the time, when I think I've caught it doing something wrong, it's actually outsmarted me. The difficult part as a mere human is staying on top of all of the different variables. So I'm going to show you my process. And what I've done is I've created a test with my test system. That's the 12-inch CPO. And I've created a test for the Orion Nebula. And the main project is this one, where it's an LRGB system. But I've also gone ahead and created separate projects for each of the individual filters so we can look at them. So the first question I have, let's look at the loom filter here, is why is this not starting at the beginning of the A period? There's a gap there. What's going on there? It seems like something's broken. Well, let's go ahead and schedule that. And now we can see that it's filled in the slew and the filter change. And that was the reason. It was leaving some time. So it actually said, let's start our slew at the beginning of the A period, and it took a while to get there. Now, I'm going to claim that's not usually a big deal. The reason for that is that the filter change took 5 minutes, and the slew took over 3 minutes. And normally, these things don't take that long. I did this intentionally for this imaging system. Here's the imaging system. And I'm going to select timings, and you can see here that I have set the slew rates to be very slow and the filter change to be 5 minutes. I did that so that I could see them in the timeline. Add that back in there so that they would show up as more than just a little spot. Okay, so that's the first question. Does it matter? Well, if it really took this long, it would matter. You wouldn't want to delay starting that much. But in general, remember this line here isn't absolutely set in stone between the B period and the A period. The beginning of this A period is somewhat arbitrary to some point. It's a really good place to start, but you could start a few minutes early, you could start a few minutes late. It's not going to make that big of a difference. So I claim that that's all right. Maybe in the future I will make the algorithm put the slew before when the imaging starts. And it actually does that under some circumstances, just not this circumstance. So that's the answer to the first question. Now let's look at the second question. Why is it showing a different start time for the AIQ than in the target selection tool? Okay, well, let's look at this. The start time is 7:14 for the luminance filter. Let's go to the target selection tool, and here's the Orion Nebula. It shows it starting at 6:50. Why are those two numbers different? Something's wrong. This is a project with multiple filters. The target selection tool doesn't know about that. It doesn't know about your project. It just knows you have an object that you might want to select as a target, because that's the purpose of this tool. So it's going to make some assumptions, and one of the assumptions it's going to make is it's going to choose a filter to be represented up here. And in this case, it's chosen the luminance filter. It's also made the assumption that what it's exposing for is the main part of the Orion Nebula. If we look at the project, go back here and open the Loom project, exposure goals, I've actually set it for the faint regions. So let's change it back to main extent and watch what happens. Now when we choose that, it starts at the same time as the target selection tool did, back at 7:50. So this is one of those little details that you have to keep an eye on. Am I actually exposing for the same part of the object? Because you don't want to be comparing apples and oranges. And that was an apples and oranges comparison. So I'm going to set this back so so that it's going for the faint regions again. We have a third question. Why is the scheduler night bar displaying the red filter on the IQ line rather than the luminance filter? So that means for the whole project here that has all the filters. Why is it showing the red filter? That's because it actually has the longest green period as the longest A period. And we can see that when we separate them. Let's look at the green filter. It's pretty short. The blue is a little bit longer. The loom is longer still, but the longest is the red. And that has to do with our weather settings. It has to do with the properties of the object and the properties of our telescope. That's just how it works out. What we're really looking at here is as M42 sets throughout the night, how low can we go before it's not high quality? And that's going to depend on the filter. So what SkyTools is saying is that the green filter is actually the one that's most constrained, shortest period of time, then the blue, then the loom, and then the red. So yeah, it just keeps getting longer and longer. Starts about the same time, but it gets longer and longer. So that's the reason it's displaying the red when I do the whole project, because it's the one that shows the longest period of time. So when you're looking at this project, you want to see the total time that is available. So it chooses the longest to show you. Okay? Why the green filter has the shortest period of time? I'd have to dig into the details, but that's a part of the software that's been tested over and over again. I trust it, but it has to do with the specifics of the filter, the weather conditions, and so forth. So let's actually just change the weather and see what happens. This hole got longer, right? The green period got longer when I changed the scene. Put it back to auto. Now, typically, the blue filter is going to have the shortest period of the night, not the green filter. But in this system, on this night, for this object, it's the green. When it schedules an object with multiple filters, like this one, it starts with the filter with the shortest period of time, the shortest period that we're scheduling for. And that, in this case, would be the green. Then it goes to the next longest, and the next longest, and the next longest. The idea being that even if this is a multi-night project, that period of time may well be getting shorter and shorter and shorter every night. So we want to make sure and get that filter. It's the rarest, it's the hardest one to do. So let's get that one first. The next question is, why did it schedule it twice? There's two green filters. It says 2 of 1 filter is ready to be scheduled. What the heck is that all about? And the answer is, there's a meridian flip. Let's go ahead and actually schedule it. We do our 2 8-minute exposures, and then it flips. And now we do 54 2-minute exposures. Why did it change from 8-minute exposures to 2 minutes of exposures? The answer has to do with the sky conditions, and really, in order to fit it in, it probably doesn't make a big difference whether it's 8-minute exposures or 2-minute exposures for the faint regions of the Orion Nebula in this telescope under these conditions. So it's gone ahead and found that 54 by 2 fit this period of time all the way to the end, where the by 8s came up short. So you're actually going to get less SNR when you stack those 8-minute images because you're not using the full period of time. That's something most people don't think about. All other things being the same, it's chosen the 2-minute exposures. There are many cases where you really need that 8-minute exposure and it won't budge on it. It's all a matter of how can I fit the most SNR into this period of time. All right, so for our last question, let's look at the luminance filter and open the exposure calculator. And it has done the same thing that we saw in the target selection tool. It has started this A period at about 650, where the scheduler is starting it later. Well, that's because we set it for the main extent. That's the default rather than the faint regions. We choose the faint regions, and now we've got a shorter period of time that starts later. So it's the same answer as to the earlier question. And remember, the great thing about the exposure calculator is that you can change things and see what happens. Let's just change the humidity to 60% and see what that does. Well, what it did, it was hard to see, is it's starting a little later in the night and it actually goes a little shorter. Okay, so let's change that to 20% and see what happens. Looking up here, now it starts earlier in the night and goes longer. Let's see what happens when we change the temperature. 20 degrees Fahrenheit. That's gone a little bit longer and a little bit earlier. That didn't make that much of a difference, not at this relative humidity. What these two numbers are doing is crudely affecting the atmospheric extinction in the model. So on nights when the temperature is much higher and the humidity is higher, we have more atmospheric extinction, and that means we have to start a little later and end a little earlier because we don't want the thing to be interfered with by the altitude. So what about the seeing? Let's set it to excellent seeing and see what it does. It really didn't change. We put it at very bad seeing, didn't make it much of a difference. Now, if you were targeting a planet or a very small high surface brightness planetary nebula and you wanted to see details, then the seeing is actually going to make a big difference up here. Let's say we want a SNR of 30. Oops. Okay, so it says 3 10-minute exposures starting at 7 for this period of time will get us an SNR of 30. Well, that was for the faint regions. What about the brightest regions? It can reach an SNR of 38 in 1 minute. Okay, so that makes a big difference. Let's look at very faint regions. Now we got a much shorter period of time to observe, and it can't even reach an SNR of 30. Let's try an SNR of 10. Because now, if you think about it, think about your image of the Orion Nebula. There's this faint nebulosity way out on the outside. In order to get a good signal-to-noise ratio, you need a lot of signal, that part of the object. It's very faint, so you're going to need to expose longer. And in this case, 26 8-minute exposures only gets us to an SNR of 9. Now, you could process your photo such that you'll never see that faint region, which means you don't worry about its signal-to-noise ratio, or you can just accept that in the faint regions, the signal-to-noise ratio isn't going to be as high. This is why we choose. Okay, so I have one last question, and it's the one that started all this. Somebody asked about it on the forum. I'm going to look at just the luminance filter, and the question is, why won't it schedule now? The progress is 79%, but it won't schedule. It should schedule to bring that up to 100%. Why is the progress 79%? Well, I put in some observations. Okay, so I put in observations that nearly completed the project, but not completely. And yet, it still won't schedule. Why? It's broken. So we found an actual problem. And this was a bug in one line of code, which was testing the wrong thing. Under this specific circumstance, it didn't work. There, I fixed it. Now it's working again. So that's an example of the kind of thing that I do when I'm looking at the scheduler to do a sanity check. You have to keep track of all the little things. You have to be careful not to compare apples and oranges if you're going to compare to the exposure calculator or to the target selection tool. Make sure you're exposing for the exact same thing in the exact same way. Remember, there's a lot more information in an imaging project than there is elsewhere. And there you have it. Thanks for watching.